Hi everyone. Today let us discuss about wireless communication. What is wireless communication? Wireless communication means transmitting and receiving any kind of data through electromagnetic wave that travel through the free space. So, the path through which the information is transmitted is known as wireless channel. So, wireless channel has a limited frequency bandwidth, so therefore a limited data rate or bit rate. To allow multiple users to communicate at the same time, the available bandwidth is divided into number of channels, then each channel can be operated in a parallel manner and independently without interfering with each other. What are the benefits of wireless communication? The first one is mobility. User can communicate while moving from one place to another place, and there is no need of cables. So eliminates the need for physical wiring, making installation easier. And easy installation, so network can be set up quickly with less effort and cost effective. So reduce the cost of maintaining cables. The flexibility, so devices can be added or removed or relocated easily. And the next benefit is wide coverage. So communication is possible over long distance using wireless networks. And scalability means the network can be expanded without major infrastructure changes. And it is used in remote areas, provides connectivity where more wire networks are difficult or expensive to deploy. So, and it supports multiple devices, and it enables modern communications which supports mobile phone, Wi-Fi, Bluetooth, IoT, and smart systems. What are the difficulties of wireless communication? The first one is uses free space as the medium. Since it uses a free space as the medium, signal travel through the air where it can be affected by obstacle, weather, and interference. Noisy and unpredictable channel. So wireless channel can be distorted or interrupted by noise and environmental conditions. Shared bandwidth. Many users share the same channel, so as the number of users increases, the available bandwidth for each user will be reduced. Higher equipment cost. Wireless devices such as antenna and infrastructure can be more expensive than some wired alternatives. And there is a limited and regulated spectrum. The available radio frequency RF spectrum is limited and it is controlled by government regulatory bodies and requires backbone network, so still it depends on wired backbone networks such as fiber optic cable and servers to provide the reliable communication services. Next, challenges in wireless communication. So the first one is efficient hardware. So wireless devices should use less power to increase the battery life. And the second efficient challenge is efficient use of radio spectrum. So radio frequencies are limited and must be used wisely. So techniques such as frequency use may have users share, it has many users share the available bandwidth spectrum efficiently. Integrated services. A single network should support voice call, data transfer, and multimedia services, and so on. And supporting user mobility. So, user should remain connected while moving from one location to another location. The network must track their locations and perform hand up smoothly when user moves from one that is between the coverage areas, and maintaining quality of services. So wireless links are prone to interference and signal loss. So the network must ensure the reliable communication, good speed, and acceptable delay. And the next one is the connectivity and coverage. Wireless network should provide continuous coverage over a wider area. Fading. So fading is nothing but the variation of signal attenuation over variables like time, geographical position, and radio frequency. So multipath is one of the major challenge in wireless communication. So this is a phenomenon that results in radio signals reaching the receiving antenna by more than one path. Then there is a uh, higher probability of data corruption. So there is a need for stronger codes, and there is a need for a stronger security mechanism, privacy, and authentication. And let us see the introduction about the wireless short-range wireless communication. Short-range wireless communication includes technologies that work short distance, that is ranging for it covers the coverage area is from a few centimeter to few hundred meters. For the past decades, wireless communication mainly dominated by cellular network. So recently, the short-range wireless devices it becomes an important part of our daily life. According to WRF, so use of these devices is expected to grow rapidly. So most of these devices are short-range wireless devices which help people to communicate with each other and their surroundings also. Examples: Bluetooth devices, Wi-Fi devices, Zigbee sensors, smart watches, wireless keyboards, and IoT devices. Now, what are the reason for spread of wireless applications? So the first one is a higher frequencies in spectrum. So there is a high frequency usage. Higher frequency bands once expensive and difficult to use. So widely employed for now it is widely employed for wireless application. And the second one is solid state devices, SSD. So modern SSD can amplify signals at millimeter frequency wavelength, that is tens of gigahertz or 10 to the power tens of gigahertz, which enables high speed communication. And the next reason is efficient and compact antennas. So the efficient planar antennas are available, making short range devices small and more practical. And the next one is the development of SAW, the surface acoustic wave frequency, which allows the generation of UHF signals using simple and low cost circuits. And the next one is digital modulation technique, which enables multiple communication channels can be to share the available spectrum, increasing the efficiency and system capacity. And the last one is circuit miniaturization. So the hybrid ICs combine analog and digital functions on one chip, and radio frequency IC responsible for compact size and cellular headphones. And what are the characteristics of short range radio? Oh, the first one is a low RF output power. The output power is up to uh, that is from several microwatts up to 100 milliwatts. That is low output power. It uses very little transmission power. And the second one is communication range. So works that is the range is up to from few centimeter to 100 kilometers, and this is suitable for indoor operations. And the antenna used in the here in short range is omnidirectional, which means that data will be transmitted, the signal will be transmitted in all directions, and simple construction and low price. Unlicensed software uses that is license-free operations operate in frequency band that do not require a government license. Uses UHF frequencies, so it operates in the ultra-high frequency range. And the battery operated both transmitter and receiver are battery operated and consume low power. It can run on battery for long time. And these are the applications of short range radio. These are the various applications, the frequency operated by the particular application, and these are the characteristics. First application, security system. It operates in the frequency range of 300 to 500 megahertz, 800 and 900. Simplicity, the characteristics of it's very simple and easy to install. Emergency medical alarms. It operates in the range of 300 to 500 megahertz and 800 megahertz. So convenient carrying, long battery life, and reliable. So computer accessories like mouse and keyboard, it operates at the range of it operates in the ultra high frequency for transmitting a higher data rate for very short range. For and Another characteristics is low cost. RFID, next application is it is used in short range is used in RFID. It operates in the frequency of 100 kilohertz to 2.4 gigahertz. And the characteristics of very short range, active or passive transponder. And the next one is wireless LAN, local area network, operating in the range of 2.4 and 5 to 6 gigahertz for continuous data transmitting continuous data rate, high speed continuous data rate, spread spectrum, and OFDB modulation. Wireless personal area network, it operates in the frequency of 2.4 gigahertz. The characteristics of medium data rate, low cost. Wireless microphone, wireless headphones operates in the frequency range of very high frequency, ultra high frequency. So the characteristics of analog high fidelity voice modulation and moderate price. And next application is keyless entry gate or car door openers. It operates in ultra high frequency. The characteristics of many transmitters are miniature and the special coding to prevent duplication is used. Wireless barcode readers. It operates in the frequency of 900 and 2.4 gigahertz. So intrusion use a spread spectrum and it is expensive. And wireless power meter, it operates in the range of 2.4 gigahertz. So the characteristics of real-time measurement of electricity consumption and instantaneous demand. And last application is IoT. So IoT operates in the frequency of ultra high frequency and 2.4 gigahertz. So the characteristics of wireless monitoring and control of appliance and industrial apparatus with minimum human intervention. What are the elements of wireless communication system? So this is the transmitter section, and this is the transmitter section, and this is the receiver section. So the transmitter section consists of data source, modulator, RF source, and RF amplifier, then antenna. And the receiver side consists of low noise amplifier, RF down converter, detector, and utilization. And the medium between the transmitter and the receiver is radio channel, that is wireless channel. Let us see each block in detail. So first we'll see what is data source. So data source, here the data can be analog or digital. So the simple devices such as the security alarm, panic button, remote controls, and will send basic, that is on off information, that is binary 1 and 0 information. When the data changes, message frame will be created and transmitted using RF signal. So this is called message frame. It consists of 3 bits, 3 address field, 3 fields: address field, data field, and parity field. Address field identify the unit from that is transmitting, which unit is transmitting the data. The data field carries the actual information, so whether it is on binary 1 or 0. So whether the current bit is binary 1 or 0, and the parity bit in general is used to detect transmission errors. FM transmission. So FM transmission, we have a pre-emphasis filter in the transmitter side and de-emphasis filter in the receiver side. So pre-emphasis filter will increase the high frequency signal before transmission, and the receiver side we have de-emphasis to reduce the high frequency and remove noise. So here we are using combander, which is nothing but the combination of compressor and expander. Compressor is used in the transmitter side to amplify the weak signal while attenuating the strong signal. And the receiver side we have expander. So expander, the reverse process is applied, so the restoring the original sound signal while reducing the background noise. RFID. So initially we know that initially data is not present in the transmitted. So it can be added in the intermediate stage by using the transducer. So RF signal is added to the intermediate receptor called a transistor. The transistor may be a active or passive. So active means it has own power source. There is no passive means there is no internal power source, which is powered by received RF signal. So here the modified RF signal received by the receiver. The receiver extract the added data and send it to the host for processing the data. So this is the tag. The reader will receive the data, then send it to the host for processing the data. And the next element is radio frequency or RF, that is RF generating section. The transmitter contains oscillator, modulator, and amplifier. So in these three functions are combined into a single transistor. In RFID, the modulation is performed remotely by RF tag. Then RF conduction and radiation. So here the conduction and radiation then with the help of is performed with the help of antenna. So here the built-in antennas use very short and simple transmission lines. Antennas are designed to be very small and compact. So most of the antennas used in short range wireless communications are omnidirectional, which allows the transmission of data in all the directions. And then the received once the data is transmitted through the channel, then the data will be received by the antenna and the receiver section, then which is given to the low noise amplifier where any noise is present which is removed by low noise, then that is given to the down converter. So that is nothing but demodulator which separates the desired signal from the other signal. So demodulation is nothing but the conversion of high frequency signal into low frequency for easier amplification and processing. So which extract the original information that is placed on the RF by the transmitter. So here the the system performance is improved by increasing the sensitivity and selectivity of the system. That is, sensitivity is nothing but the ability to detect weak signal. Selectivity is nothing but the ability to select the particular that is range of signal while rejecting unwanted signal and interference. So here the improvement is achieved while considering cost size, power consumption, and physical limitations. Another the common modulation technique used here are ASK modulation and FSK modulation. ASK modulation is nothing but amplitude shift keying modulation or on-off keying modulation, which is nothing but the digital version of amplitude modulation or AM modulation. FSK is frequency shift keying modulation, which is the digital version of FM. And we can see the AM and FM waveform. So for AM modulation, so this is message signal, low frequency or baseband signal, and this is the high frequency signal or carrier signal, and this is the modulated signal. Amplitude, since the amplitude of the carrier signal is varying, the modulation is called as amplitude modulation. So here the amplitude modulation means the characteristics of carrier signal. So that is the properties of carrier signal, whether it is amplitude or frequency or phase, it's varying according to the instantaneous value of the modulating signal or message signal. So here if you see when the amplitude increases, when the amplitude of the message signal increases, the amplitude of carrier signal is increases in the modulated signal. Then it is decreasing from the this end to this end. So again the amplitude of carrier signal is decreasing, then again it is increasing, the amplitude of carrier is increased, then decreased. So like that the modulated signal will be generated for AM modulation. Whereas in FM, so there is no change in the amplitude. Amplitude remains same, only change in the frequency. In that is the change in time period. This is message signal and this is the carrier signal. For FM, when the amplitude of message signal increases, the carrier of the that is the frequency of the carrier signal will be increased. Okay, so that's what here we are getting the signal like this. High frequency means the time period will be less. As the amplitude decreases, we are getting another kind of frequency. Again, when the amplitude increases, we are getting higher frequencies. So this is called FM. In FM, there is no change in amplitude, only there is a change in the frequency, whereas in AM, there is no change in the time period or frequency. So only amplitude changes. The other two parameters remain same. Then the next element is power supply. So in short range wireless communication, at least one device must be operated without any wired connections. So small devices such as remote controls and security sensor have limited battery size and energy. So the frequent battery replacement is inconvenient and costly. So we are going for low power. So low power consumption is a major design while we are designing the device. Low any short range wireless communication, we should concentrate on the low power, and reducing the power consumption is more challenging for receiver. Then many applications use intermittent transmission. So transmitters stay in low power standby mode, become active only when the data needs to be sent. Okay, so that is thing in short range wireless communication system. The receiver must be continuously listening for incoming and consuming more power. So that's what the design of receiver with low power is a challenging one. To save energy, the receiver may operate with a reduced duty cycle or stay in a low power stand mode and switch to normal mode when the signal is detected until the signal is until there is no signal. The receiver will be in standby mode. So these power saving methods may reduce the receiver sensitivity. The next one is wireless fidelity. So wireless fidelity or Wi-Fi. So Wi-Fi follows IEEE 802.11g standard, and the maximum data rate transmitted by wireless is 54 megabits per second, and it covers up to the range covered by Wi-Fi is up to 100 meters. It operates the frequency of 2.4 gigahertz, and it provides secured communication. So password encryption is available in Wi-Fi communication, and the kind of modulation used in Wi-Fi is OFDM. So OFDM means orthogonal frequency division modulation. So this is used for encoding data on multiple carrier frequency and is a Wi-Fi device. So what are the applications of Wi-Fi? So Wi-Fi internet access are used in internet. So internet access through cable or DSL modems, wireless connectivity for laptop, smartphone, and tablets. So device-to-device communication is possible, and file sharing is also possible through Wi-Fi. And the smartphone and IoT device also working in Wi-Fi can be worked in the Wi-Fi. Then advantages are, so the data rate is since the data is high, the high speed transmission is possible, and the minimum cabling and infrastructure is required, and the installation is very easy, and it can be moved from one place to another place easily, and it is widely available in home, office, and public hotspots. And the disadvantages are, the coverage area is very less. So that hotspot, if we take this hotspot, the coverage area will be very less, and the performance will be affected by obstacles and interference. Since it is transmitted without any wire, the performance will be affected by the noise and surroundings. And security risk, if the device is not properly configured, then anyone can access the Wi-Fi. So security risk is also there, and the installation and maintenance cost. So the maintenance cost is high. Then let us see how the data is transmitted from one system to another system through wireless. So the data from the computer is transmitted, that is digital data that is given to modem. Then the modem will transmit this electrical signal into that is binary signal into electrical signal that is transmitted through the cable, that is telephone network. Then the receiver side we have another modem, so that is that is for demodulating the analog signal. Then the analog signal is converted back to digital signal that is given to the another computer. So there are three Wi-Fi network connections generally. So basic service set, distribution system, and extended service set. So basic service set. This is basic service set. So it contains only the stations that these stations can be communicated within this BSS only. So if they are within the wireless range, so it cannot communicate. The station one cannot communicate to station three in BSS. Only within this one is possible. In ad hoc mode, stations connect directly to each other without an access point. So if we want to communicate to station 1 to station 3, so we have to use access point, so which connect multiple BSS. So that is nothing but distribution system. So this create extended service set which allows communication between stations in different BSS. So stations connect to, so in the distribution network system. one station. So this station can be connected to station 1 can be connected to station 3 through this access point. So stations connected to the nearby access point. S1 connected to AP, this AP, ST3 connected to this AB. Then multiple ABs are connected through wired or wireless link. Then APs will exchange the data between them. So the connection between station to AP and AP to station. So then the data will be transmitted from one AP to another AP, then this AP to this station. So important thing is media, that is the media connecting a station to API and connecting AP to another API are totally independent. Extended, next one is extended service set. So here multiple BSS can communicate with each other. So user can move between different bases while connected to the same network. So here this portal will act as a gateway between Wi-Fi network and wired network. So it connects AP to wired media and coaxial cable, or that is AP to wired media, then such as coaxial cable or twisted pair. Then authentication verifies whether the device is authorized. And then encryption protect the data by converting into secure form. Then additional security is also provided in this. So here portal is a gateway between the wired and wireless. Next one is Bluetooth. Let us discuss Bluetooth in next class. We will stop with this. Thank you.